have the ground substance, that background kind of semi-fluid gel kind of stuff, and embedded in said ground substance would be the different fibers. The most common fiber would be collagen, right? What do you call the stretchy fibers? Elastic fibers. And how about little thin collagen fibrils that form a network? Those would be reticular fibers. And the word reticulum just designates how they're kind of formed, like a scaffolding, like a netting, upon which cells might be supported or sitting on there. All right, so locations, and again, the book gives you a whole bunch of different locations. I'll try to give you in the slides and canvas the most obvious locations, the larger locations. So for reticular tissue, by the way, reticular tissue, take a wild guess. What might be the most abundant type of fiber in the matrix? Would be reticular fibers. Again, chemistry-wise, they're made up of a collagen fibril. So that's the biochem. But don't worry about that. Just give you a little bit more information. So reticular tissue, it's forming this networky kind of thing. Those are the fibers. They're actually hard to stain, so it takes a very specific chemical formula to get these things stained. Locations would be liver, spleen, lymph nodes, and bone marrow. The book doesn't really mention liver that much. It's mostly like lymphoid type organs, but it really is supported by this reticular connective tissue proper. All right. So then we can talk about very highly fibrous tissues. So when you talk about fibrous tissues, that refers to lots of fibers, right? For the most part, they would be collagen fibers. Depending on how these fibers are arranged, you could identify either a dense irregular CTP. So in this case, the fibers are arranged not all in a linear fashion. They kind of form like a basket weave, kind of irregularly arranged. But we still have a whole bunch of fibers present. It's highly fibrous, a lot of collagen fibers. And again, structural strength and so forth. Now, I have some issues with some of this terminology. Here's my big issue with this thing. As far as locations of dense irregular CTP, that's a type of connective tissue. It forms, as far as where it's located, most of the dermis. We've got epidermis, then we've got the dermis. Most of that is a dense irregular CTP. But it's called the reticular layer. What? Write this down, and if I ask you a question regarding this kind of weirdness, I'll tell you in advance what the question is or whatever. See what I'm saying? It's not reticular tissue, right? It's a dense irregular CTP. So they're going back to that term reticulum, which means network E. All right, so kind of write this down, think about it, not too long. Fibrous joints, capsules also would be a dense irregular CTP. But here's the big one. 80% of the dermis, what kind of tissue? Dense irregular, but that layer is called reticular layer of the dermis. By the way, we'll talk about dermis in just a few minutes, because that's the next chapter on the skin, right? Even though, bless you, don't be getting sick. Okay, so even though dense irregular CTP, the large ropey things are kind of going in different directions, there's still a dominant pattern. There's still a dominant orientation of those collagen fibers. And those are called tension or cleavage lines. Why would that be important? If you are a surgeon cutting into the patient's skin to get to whatever, you will then, would it be better to follow the main orientation of the collagen fibers or go across them? go with the orientation, right? Because that would be easier for the skin to heal. So rather than cut across it, right, you go with the main orientation. And there's actually maps of the human body which indicate those main orientations of the collagen fibers. See what I'm saying? Go with the grain, right? It's easier to heal. I mean, you can still get to a body part by going across them, but cosmetically, you're going to have, you know, scar tissue more apparent. Talk about that more in just a bit. Then, let's see. If there's dense regular, there's probably, if there's dense irregular, there's probably dense regular CTP, right? And here, as the name applies, the collagen fibers are kind of all going in one direction. I mean, to be sure, they're kind of wavy, right? You could straighten them out. Can you stretch them? Nope, they will tear, right? But dense irregular CTP, again, fibroblasts are the main cells. Fibroblasts are the main cells in pretty much all of the different types of connective tissue proper. Think of fiber, blast, B for builder, they're building these fibers, right? And here, dense irregular CTP. Even if you haven't dense regular CTP, if you haven't heard of it, you have heard of tendons, ligaments, aponeuroses, right? Make sure you're clear on the difference between a tendon and a ligament. They're both dense regular CTP, but tendons attach muscle to bone, and ligaments would be bone to bone, right? But histologically, they're almost the same kind of tissue. This is very, very strong tissue. Although tendons and ligaments do tear, typically other injuries could occur first, like the bone might fracture, depending on the, you know, the patient and so forth. Now, an aponeurosis is a very wide tendon-like thing. Yeah, so one aponeurosis that you're probably aware of maybe is this aponeurosis on top of your head. You know, it doesn't seem like a muscle right here, right? But up in front, there's a muscle up in front here that's called the frontalis muscle, right? And there's a muscle in the back called the occipitalis muscle, right? But between, there's no muscles up here, right? That would be that wide tendony type thing. It really connects muscle to muscle, maybe some bony prominences. So these wide tendon-like sheets are called aponeurosis. Why is that a bad term? Kind of looks like a neuron, right? Has nothing to do with that, right? But I guess it's close to the brain or whatever. It's really not close to the brain. So we've got the frontalis, right? In the back we have another muscle, the occipitalis, connected by that aponeurosis. It's called the gallia aponeurotica. So it's kind of cool. If you contract your frontalis muscle, like you raise your eyebrow, do you feel a little tugging in the back? Sometimes the ears get involved.
Yeah.
Isn't that weird? That's, I love muscles, facial muscles. Muscles of facial expression are awesome. Anyway, that's an example of an aponeurosis. It has nothing to do with neurons. All right, let's see. Then we have elastic CTP. And again, an elastic CTP. This terminology works out and I have no issues with it, right? So an elastic connective tissue proper, the main fibers are elastic fibers. That all makes sense. So elastic fibers within this elastic CTP are giving the structure within which they're located stretchability. So think about where this stretchability thing might become handy. Do I have them over here? Okay, the walls of large arteries. So we talked about this before when we talked about the vertebral arteries, right? So we've got the corazón, the heart. Blood vessels that carry blood away from the heart are called what, please? Arteries. Become smaller arterioles. Become the smallest blood capillaries. Then heading back to the heart, venules and veins, right? So that's the little circuit, right? So which blood vessels, let's just break it down to arteries and veins. In which blood vessels, arteries and veins, would the pressure within them, the blood pressure, be higher? Arteries or veins? Arteries, exactly right. Because the heart contracts. The heart is a muscular pump. And the two larger, inferior little chambers, the ventricles, these are strong muscular thingies. When especially the left ventricle contracts, right, boom, it directs blood at very high pressure and velocity into the arteries. That's the first thing, right? So, got a bunch of pressure going into the largest artery in the whole world. Anybody starts with an A? The aorta, right? So, here comes all this blood going into the aorta, and the aorta, because it has elastic CTP, it's got the stretchies, right? It will stretch, and then when the blood continues on to the next part, it will recoil, right? Also, the large artery's ability to kind of stretch and recoil kind of equalizes pressure within the other blood vessels, right? Because why is that important? The other blood vessel walls are getting thinner and thinner, right? So you don't want any damage at that level as well. So aorta, the large arteries, we've got elastic CTP. Ligamentum flavum. Flavum means yellowish of the vertebrae. Those are, so ligamentum, kind of, you think of a ligament, but it's actually mostly elastic CTP. And these ligamenta flava would be between the laminae of the vertebral, between the vertebrae. Remember, on the vertebra, we've got the spinous process, right? And on either side, we have a lamina. And you stack them up. I don't have a picture on this. But between the successive laminae, we have this elastic CTP known as the ligamentum flavum. So that gives you a lot of, bendability, stretchability, and comes back to kind of recoils. Then we've got this other big thing called the ligamentum nuchae. Nuchae means neck. So there's a huge ligament, very strong, from the base of the skull to some of the spinous processes, especially spinous process of C7. You can kind of grab, there it is, okay. And also that is a very stretchable kind of thing, bend, flex, and extend, ligamentum nuchae. Walls of bronchial tubes, yes, we have some elastic CTP there as well. Now, the last slide of this chapter kind of puts together the two types of tissues that we discussed here, which would be epithelial tissues and CTP. So when we talk about these epithelial membranes, they would include, let's start with, let's go kind of backwards. We have the serous membranes. Serous membranes, let's see. Serous membranes, ventral body cavities, and remember the three words start with a P. Cardio for the corazon, right? Plural, and the peritoneal. Peritoneal means to stretch around. So all of these cavities are defined by serous membranes. Remind me, how many layers is each serous membrane composed of? Two. The outer pared, the wall, is the parietal, right? So we have the parietal pericardium, parietal pleura, parietal peritoneum, right? And then the one sitting right on the visceral organ would be the visceral serous membrane. Each one of those membranes is composed, so we're going for what? Epithelium and CTP. And in serous membranes, you're going to have that simple squamous epithelium and CTPs. Together they form the serous membranes. A little bit more complicated than that, but this picture, however, down here kind of, you all okay? Oh, okay. So somebody asked me about the peritoneum. It's kind of confusing. So the organs, abdominal pelvic organs, that are closer to the anterior abdominal wall, and they're kind of invested or within this peritoneal double serous membrane, those are called either peritoneal or intraperitoneal. Two words for the same thing. So they're surrounded, protected by the peritoneal membrane. But organs that are not covered by these serous membranes, they're kind of behind the peritoneal cavity. What would you call those? Retroperitoneal. Things like kidneys and pancreas, part of the colon, things like that. So in this lateral view, you could kind of see that thing. So peritoneal, intraperitoneal, oh, it's probably a kidney situation, or a transverse colon, that would be retroperitoneal. All right, so serous membranes line closed body cavities, whereas mucous membranes line cavities that open to the outside of the body. Mucous membranes open to the outside of the body. Respiratory, yep, opens to the outside, right? How about digestive? Yes. Also, right? How about reproductive? Yes. Digestive, then urinary system as well. Anything that has openings to the outside, all of these systems are lined by a mucous membrane. Now, there the epithelium might change, but you always have epithelium, a little bit of CTP on the other side. In mucous membranes, which cell type would you expect to be very common and abundant? Starts with a G.
Oh, goblet.
Goblet cells, right? Got a bunch of goblet cells producing mucin, combines with water, and you have mucus. So all of these mucous membranes have a sprinkling of goblet cells which produce mucus. All right. And then finally, the reason I kind of went kind of backwards is that the last type of membrane is called the cutaneous membrane, which is the skin. And again, we've got the epidermis, we've got the dermis, we've got those two components. And that leads us right into chapter 5 on skin, cutaneous membrane. So, I saw these guys, at first I thought it was 2 of them. I guess there's 3 of these cute guys. Are these Shar-Peis? Is that what they're called? Anyway, they're comfortable in their own skin, right? Look at that. How cute are those? Are they big? Do they get big? I don't know. They look so cozy. Anyway, so chapter 5 is on the integumentary system, aka the skin, and all of the structures associated with skin. So what kind of things are associated with skin? You've got hair, you've got nails, anything else just come out of the skin? Right, so we got all sorts of glands, right? Got the sweat glands, we've got oil glands, we've got the hair stuff going on. I don't spend too much time on hair and nails, maybe a little bit on hair, just a couple of things. But integumentary system, aka the integumentum, is the skin. This is the first organ that we're talking about. Skin is the largest organ in the body, right? So followed by the liver. It actually, I think, what's the body weight? It's 7% of person's body weight. You could look it up. Is that 7%? So that's quite a bit. And the epidermis is constantly, changing, sloughing off. This is kind of the gross part. I don't know if you read the book, but over a lifetime, we shed over 40 pounds. 40 pounds of that. Where is it? That's so gross, right? But that's a lot of stuff, right? but all of these cells will slough off. Before we continue, what is an organ? Because we talked about cells, we got tissues. So what would be an organ? Organ would be various tissues working together, right? So in skin, let's see, integumentum skin. Okay, let's go through the list. Do we have epithelial tissue there?
Yes.
Yes, that would be the epidermis. Do we have connective tissue? Yep, we've got the dermis, which is a CTP, right? Do we have, let's see, muscular tissue? In the skin? Do we?
Yes.
Yeah, but where it's not like biceps, right? But associated with each hair follicle is a little smooth muscle cell called the erector pili muscle, and especially on a cold day like today, right? When the skin is exposed to stress, it could be heat, it could be fear, or in our case, lack of heat, then those erector pili muscles, I mean, they're attached to hairs, they contract and they bring the hair up, right? Or if you're scared, well, they say, oh, the hair is on the back of your neck. I don't think I have that many hairs. But anyway, you know what I'm talking about. But if not, if you've got dogs or cats, you know what happens when a dog gets really upset, right? Right? So their erector pili muscles contract and they look fuzzier and furrier and scarier to the enemy, right? And then maybe when they get all furry like that, they still get bitten, but hopefully not too much, or the biter will get a whole bunch of fur rather than, a lot of things like that. So, okay, so we got muscular tissue. All right, do we have nervous tissue in the skin?
Yes.
Oh, yeah. And that's important because you feel, cold again. We've got the heat situation, we've got pain receptors, itch receptors, things like that. So that would be innervation. So there's nerve stuff in there as well. So therefore, skin does meet those criteria. It's usually all different types of tissues that form the structure for a common purpose. So then we can take a look at this one. So functions of the skin. Well, protection, that's an important one, right? Protection. Temperature regulation. Okay, so it's like 30 below, right? So over here, when the temperature is really cold, the blood vessels within the skin will constrict, right? So your skin, and also that means the skin gets cold, right? Yesterday, I thought my fingers were frozen. I walked around like that. So how would that help with a cold, when you're very cold? You vasoconstrict the blood vessels in the skin. That directs more blood to the interior, right? So that will kind of keep you warm-ish, right? The opposite would be vasodilation, right? So when it's super warm, you go outside, maybe there's some sun, whatever, and then you kind of feel a little bit more flushed, right? So that means that the blood vessels in the skin will blood vessel dilate. And that's to bring more blood to the surface. How does that help you cool down?
Heat.
It releases heat, exactly right. So temperature regulation is really important. Again, vasoconstriction and vasodilation. How about sweat? Does sweat help us with anything? Well, yeah, when it's really hot and you start sweating, right? That sweat will also cool off the surface of the skin, hopefully bring the body temperature down a little bit. Excretion. Oh, well, when you think about the excretory organs, of course, you think of the digestive system releasing fecal material. You think of the urinary system releasing things that we need to get rid of, like urea, uric acid, things like that. Did you know that the skin is also a mini excretory organ? right? Because when we sweat, especially in the sweat, and sweat is mostly water, right? It's kind of a weird thing, but within the sweat, you're also releasing salts, urea, and uric acid. That would be a component of sweat. So an example of that, again, back to dogs. How many of you have a dog? Or I don't think cats do that, okay? I love dogs. I love cats. Well, I'm a little scared of cats. But anyway, so dogs. So do dogs run up to you and lick your face? Yeah, oh, my daughter has one of those doodle things. Golden doodle, this thing is stretchy, and this is big dog. Anyway, she likes me, the doodle. So yesterday I was visiting over there and my face got licked, right? Because a dog likes me, right? But why are they licking?
You taste good.
Because you taste like a potato chip, right? And actually we went for a walk and then, so they like the salt in there, right? Do cats do that? Not sure. Yeah, cats are a little scary to me. I like them, they're cute. Production, all right, vitamin D. So, how much time should you spend in the sun? So that's kind of you don't want to be out there too much because then you get skin cancer, right? If you're not there at all, then you might have bone problems. So I think, 10 minutes in sunlight a day, naked? Well, that's not gonna happen for me, because you want body surface, so that ain't happening, right? I don't know. But the sun is a really good source of, this vitamin D, right? Sun produces vitamin D. And then how many of you are taking nutrition? You could help me out here. Nutrition? No. So vitamin D. All right, so that will then facilitate the uptake of calcium into bones, because that's really, really important, right? So for strong bones, you need to get vitamin D. You get vitamin D from what, CVS? Well, I guess you could buy it there, right? Or I guess the sun would be a better, more natural way of doing it. So a little bit of sun, too much sun, then you get cancer. So I don't know. Moderation, I guess that's the only thing I could think of. Now, sensory reception, this is important as well. Just a couple of seconds on this. So, remember, nervous system is my favorite. You'll notice I have a lot of favorites. Muscle, my favorite. This is cool too. Anyway, so when we get to the nervous system, which is basically brain, spinal cord, bunch of nerves, right? We're going to talk about the direction of information flow to the brain and the spinal cord. So you can either have information flow, by that I mean neurons and axons, synapses, wires. It's all wiring. And when that information is collected from different parts of the body, both externally and internally, that incoming information is called sensory or afferent, right? So, for example, I'm putting my hand on this probably very dirty table, but it's still kind of cold, so I could feel that cold. Afferent sensory saying, oh, this is really cold. If you put your hand on a hot plate, we're going to remove it real quick, right? That's also incoming information. Or, I know that this is my, my little gadget right here. Incoming information, both from the external environments, right, on the outside, and internal environment. How about internal environment? Give me an example of something happening inside the body that needs to be brought up to our consciousness. Well, it could be, yesterday I ate way too much guacamole. Okay, I'm good. But let's just say I ate too much, right? So the stomach stretches, right? And sensory, it's like, stop it, okay? Or urinary bladder fills up with urine, you need to go, right? So incoming is sensory information. Then what you do with that information will determine the output from the brain and the spinal cord, right? So for example, and that's called motor. Incoming sensory, sensations, that makes sense. pain, temperature, whatever, internal structures that are stretched, whatever, menstrual cramps, we know about those. Anyway, so that's sensory or afferent. How you react to that information would be motor or efferent, right? So again, this is pretty much chapter 12 in a nutshell. But if you put your hand on a hot plate, that incoming information is sensory, right? What you decide to do about it would be motor, okay? Think of motor muscles, right? So then you engage skeletal muscles or smooth muscles or what have you to mitigate that incoming stuff. But all of that I just went through just to tell you that within the skin we have crucial sensory receptors that tells us about what's going on with the outside world, right? Heat, cold, pain, pressure, what have you, right? So we'll talk about that as well. The next slide, again, pretty much all of these are from your book. I think this one's in there too. This is the integumentary system. Integumentum, skin. Keep it simple, right? And this is a really cool step dissection. So basically going from outside in, external to internal, or superficial to deep. That would work, right? So we've got the skin, two parts to it, the epidermis, keratinized, stratified, squamous, epithelium, right? And deep to this epidermis, we've got the dermis, right, which is CTP. Somebody asked me on Monday after lecture, was a good question. So as far as how does the epithelium and the CTP, how are they arranged? Without exception, you've got epithelial tissue sitting upon a non-living basement membrane. It's very, very thin. And on the other side, without exception, always you have CTP. Epithelium sitting on a non-living basement membrane, very, very thin. Got those two parts, right? And CTP on the other side. Epithelial tissue doesn't have blood vessels. No. What do you call that condition? No blood vessels. Avascular, right? Whereas CTP is highly, highly vascular, right? And it's through this long-range diffusion that the cells of the epithelium get all the goodies like oxygen and glucose and release stuff in return. So again, we've got the epidermis, we've got the dermis, and then deep to the skin itself, under the skin, you've got the hypodermis, which is also known as the subcutaneous tissue and also rarely used superficial fascia, right? The reason I bring that up is because it's rarely used, but sometimes it is, but to differentiate between superficial fascia and the what? Deep fascia. And deep fascia would usually be a type of a CTP, depending. And deep fascia surrounds muscles and organs and so forth. It's, kind of a membrane region associated with a lot of body parts. Anyway, and then we've got, here's the muscle tissue right here, maybe more deep fascia in this region. So again, integumentary system, we've got the epidermis, deep to that is the dermis, and then we've got the hypodermis or subcutaneous tissue or superficial fascia, and then deep fascia, depending on where we're looking at, right? All right, so hypodermis, what kind of tissue is it? Adipose tissue. That's your fat tissue. So hypodermis, remember talking about where we carry fat, it would be hypodermis, right? You've heard of visceral fat? Right, that's a big thing right now. Everybody who wants to get rid of their visceral. Where is this visceral fat? Well, viscera means organs, right? So typically, when they talk about visceral fat, typically, depends on who you're talking to. So it's not very well defined. It would be the fat sitting within this double peritoneum surrounding the abdominal organs. They're called mesenteries. That's for later on, but visceral fat. It's kind of just within the last 5 or 10 years that that's become a thing. Okay, but we carry it. And also orbital fat for the eyes, right? And the kidneys, exactly, are also supported, protected by fat, renal fat. Anyway, that's really important. All right, so now check this out. So basically, I think I used this slide, I've really got into it several times to pick out different things. So we've got the skin going on here. All right, we've got the epidermis, right, which is a keratinized, stratified, squamous epithelium. So keratinized, keratin is that waterproofing protein, right? Stratified, how many layers? More than one, and in this case, many, many, many layers. When you exfoliate, by the way, you know, with exfoliation, you get that, whatever it is, that scrubby thing, right? And you exfoliate, and you look all, you know, smooth. Don't exfoliate too much. Don't do that too much, right? Don't get really into it, especially if they've got wet. What's the grainy stuff? Anyway, get something gentle or whatever. But because if you start oh my goodness, it feels good until you get into the dermis. That's where you could draw blood, right? Yeah, so be careful. Be careful with your skin routine. Epidermis. Now, the epidermis is sitting upon a basement membrane. Very, very thin, 2 layers. Basal lamina and the reticular fibers kind of supporting it. Very, very thin. As we'll see in slides, the basement membrane is rarely visible as a clear line, but it's there. Then on the other side of this basement membrane, you've got this beautiful dermis, right? CTP, couple of parts to it, and here these fat cells, what do you call fat cells? Adipocytes. The tissue is adipose tissue. It's a type of a CTP, right? Going back to the epidermis, do you see blood vessels there? Nope. Avascular. But, oh, look at that. So this is a nerve ending. Look at that. So epidermis is avascular, but it is innervated. It's got nerve supply to it, right? In the dermis, check this out. We've got blood vessels going on. Oh, here's that hair, right? And this guy right here, that's the little muscle I was talking about. How wonderful is that? The smooth muscle responds to stress. We'll talk about stressors like temperature and stuff like that. All right, so then, yeah, sure. It is innervated. So the epidermis avascular but innervated. The only tissue that is both avascular and not innervated. Does anybody know what's the only tissue? Doesn't bleed, it doesn't hurt. Skin. No. Cartilage tissue. Cartilage tissue is the only tissue that is both avascular and, but if you're gonna pierce your ear, right? What is this called? What kind of piercing is that? Anyway, this thing right here?
Cartilage piercing.
Cartilage. Okay. Be careful with that, right? Because does anybody have one of those?
It hurts
Yeah,
so
my
bad.
daughter just had it and I go, oh, I don't like needles. I don't like it. But anyway, so she got that done and it got infected.
Yeah. Takes a long time to heal.
It takes a long time to heal. Why? It's avascular, right? The reason it hurts is because to get to the cartilage, you have to get the skin, right? So anyway, you know, get those little, I told her, why don't you get the ones, can't you glue something on, right? And then take it off. But she has to go on antibiotics because this thing was just really, it took forever.
Wow.
It looks all cute now. Okay, so we have 2 types of skin, and that would be thick skin and thin skin. This slide is not from your book. It's not terribly important, but I wanted to go kind of dramatic on you. So thick skin, don't worry about all the numbers right here, right? But look at thick skin, look at this is a very pretty thick epidermis, right? And here is the dermis, that's thick skin. Thin skin, oh, look at that little tiny thing, right? Very thin. Most of it would be the dermis, that would be thin skin. Thick skin and thin skin, only two types of skin. Where would you find thick skin? On your body. Yes, palms of your hands and the soles of your feet. So that's where the epidermis is really very, very thick. And everywhere else on your body you would have thin skin. All right. Other than the thickness of the epidermis, thick versus thin, what are the other differences? So check your palms. Don't take your shoes off it. Okay, so here's the palms. Here's the back. There's no hair. That's a good thing, right? I mean, that's a whole new thing going on, right? If we had hair on our palms, oh man, that would be weird. So no hair, right? When you get home, check the soles of your feet. Should have no hair over there. And associated with hair would be what? Ooh. Well, we sweat through thick skin, right? We get nervous and... So when you think of hair, always think of the associated oil glands, right? Oil glands. And the oil will help the hair, grow, and it has antibacterial things and so forth. So thick skin, again, you check for hair, right? No hair. Check for sweat. Yeah, there'll be some sweat. But how about oil? No oil. Can you imagine taking a shower and your soles of the feet get all oily? That's kind of dangerous, right? Unless maybe you had hair too. Anyway, so thick skin, palms of the hands, soles of the feet, no hair, and no oil glands. Yes for sweat glands. Yes? Okay. Then the other kind of more superhistological thing that I want you to know is that in thick skin, within the epidermis, there are 5 layers. In thin skin, within the epidermis, there's only 4 layers. A stratum is a layer, okay? Now, back to soles and feet. Has anybody unfortunately ever gotten like a sunburn? I've burned quite a bit, right? So you got a sunburn. Has anybody ever gotten a sunburn on the thick skin? Yeah, I mean, it could happen, right? But thick skin has that extra protective layer against ultraviolet radiation. All right. So then, let's take a look at the different layers of skin. But before we do that, I'm going to go to this slide. I'll go back to now. So now we're just talking about the epidermis. Don't forget it's a keratinized, stratified, squamous epithelium. We got that. Then the question is, what kind of cells are there? Well, here they are. So we have, this is important, keratinocytes. Keratinocytes, sounds like keratin. Keratinocytes are the main cells of the epidermis. Keratinocytes. Keratinocytes, remember we talked about how you get a whole new epidermis every 35 to 45 days? When we say that, it means that each of the keratinocytes, right? They start over here, they're sitting on the basement membrane, they divide, and then they migrate through all of the layers of the epidermis. And that migration or moving of a keratinocyte from this bottom layer to the top, that journey takes about 35 to 45 days. And as they migrate through all of the layers, they change their shape, right? And then ultimately, about halfway through, maybe 2/3 of the way up, they're completely dead, right? So they just become like these dead, flattened sacs of keratin. And they still do a purpose, right? Because they still give you the waterproofing thing. But the other kind of creepy thing is, when you're looking at your skin, it's all dead stuff we're looking at. Isn't that kind of gross? But it's still, I know, it's not, yeah, too many weird things, but it's true. Anyway, so we've got the keratinocytes, then we've got these tactile cells, okay? They used to be called Merkel cells, named for the person who discovered them. Tactile, right, like touch receptors. Check this out. So here's that tactile cell, right? And look at that, it's got these little arms going on, right? And it's receiving information from other parts of the skin. Exactly how this occurs, I don't know. But those sensations of touch have to be hooked up to a nerve, a neuron, and this would be a sensory nerve. There's different types. So that will give us information about if somebody, if you're touching something, right? Sensory, okay? Then we also have dendritic cells. These used to be called Langerhans cells. But dendritic cells, look at that, how cool are they? Don't like this term because there's dendrites in neurons. So that's confusing. But the word dendros, from the Greek meaning tree, so they have lots of branches going on. Dendritic cells have these arms reaching out. And dendritic cells, look at that, they go all the way up here, they're pretty big. And if there is like a bacterial cell, or viruses might be too small, I'm not sure, but these tree-like cells are going to reach up and grab those pathogens, and then they move into the dermis primarily and present that pathogen to cells that might be able to destroy it. Like maybe there's macrophages down here, right? Isn't that cool? So there's a lot going on. Your skin, that's a lot of activity there, right? I keep thinking, isn't this really the coolest thing to think of, all the stuff going on? Why don't we do like a video game on this, right? I would play it, but we're doing other stupid stuff. But this would be so interesting, have all these activities, get a bacteria, the bad guys, and just a thought. We need to make a lot of money somehow, get some heating in here. So we got the dendritic cells, that's cool. These guys are really cool too. These are called melanocytes. So that sounds like what?
Melanin.
Melanin. So, and that's a pigment, it's a color, right? We'll talk about skin color. So skin color, melanin, the lighter skin tones or the darker skin tones or variations or whatnot. First of all, there's different types of melanin. So some of it's darker, that's eumelanin, there's a pheomelanin, something else, doesn't matter. But it gives you pigment. Now, that melanin, the pigment, is produced by melanocytes, right? Melanin producing cells. And the melanocytes, look at that, they're making this melanin, which is a protective pigment that will then, this is really cool, it will align, goes around the nuclei of keratinocytes, protecting the nucleus from ultraviolet radiation. Is that neat? Because, remember we said too much UV not good, not enough is not good either, right? Ultraviolet radiation, and we talk about skin cancer, right? The most common. What occurs? Well, when the DNA is damaged, that could then have cancerous effects on the cell, right? When the DNA is damaged. And it's damaged by ultraviolet radiation. So when you protect it, put like a little blanket of melanin around there, then the ultraviolet radiation is less likely to get into the nucleus and mess up the DNA, right? So how does this work? Well, melanocytes then, look, they have these arm things going on too. So they're producing melanin, and within the arms, whatever these things are called, I don't think they have a name, they will inject the melanin into the keratinocytes. And then that melanin will be surrounding the keratinocyte nucleus, protecting it from ultraviolet radiation. Okay, so it's a good thing to have this color, right? So let me ask you this. If you consider somebody with light skin versus darker skin, right? Light and dark. Which individual with light skin or dark skin would have more melanocytes? The lighter or the darker skin person? Same. Same number of cells, but remember the melanin does not stay within the melanocytes. It's injected into the surrounding keratinocytes primarily, right? In persons with light skin, that melanin does not stick around too long. It's broken down by an enzyme, all right? In persons with darker skin, the cells are more efficient in keeping that melanin. So typically, if you have a patient with super light skin, what are you going to advise them to do when they go to Hawaii? Sunscreen, right? SPF 200 or whatever. Is that still work? Whatever, and then it comes off and you put it on. Anyway, but when you have darker skin, then you're better protected against ultraviolet radiation. So if you're lighter skinned and if you're able to tan, if you're able to get a nice, wonderful suntan, a safe one, right? But then you come back to San Francisco and you sit in the library, put the next one. Don't do that either. How long will it take for that suntan to fade?
A few days.
35 to 45 days. Why is that? Because those keratinocytes that were nicely protected, oh no, they're going up top and they're sloughed off, right? So that's kind of interesting too, right? So yep, it's about the presence or absence of that enzyme. All right, did we cover this? So now we're going to go back to this picture. So this is kind of a lot, but yeah, you probably should know this pretty well, because if you look at the different layers or strata of the skin, then it will be easier for you to figure out or mentally have a picture of what happens when your patient has basal cell carcinoma. That's the most common. Or squamous cell carcinoma. Or what is the most dangerous type of skin cancer? Anybody? Malignant melanoma, right? And that's when which cells become involved? The melanocytes, because they too could become cancerous. And the reason that when you think about cancers, and some of them are, less deadly, the other ones are more deadly, what determines that? How fast that initial cancer spreads to other parts of the body. What do you call that spreading? Starts with an M. Metastasis, right? So you don't want stuff spreading to other parts of the body. You want to kind of contain it and address it as soon as possible. Now, melanocytes, where's the melanocytes? Here's the melanocytes. So melanocytes, if this cell becomes cancerous, it's a very aggressive cancer. It starts to divide very, very quickly, the cell, and look at that. It's very close to the highly vascular what? Dermis. And then once those cells get into the bloodstream, they could travel to other sites. And that process is pretty quick. I know of two relatives who are living with malignant melanoma, and they're okay, but they have to get checked all the time. One of them, guess where the melanoma started? Between their toes.
Oh, wow.
So y'all gonna go home and check between your toes, right? So check your body. I think about once a year, you should go to a dermatologist and have your body scanned. Look for any weird things. I do that not every day, but once a year, and my dermatologist says, okay, let's check you out again. And I won't show you today, but she found this weird thing on my shoulder. She was really deep, and it could be either something really bad or it's like some weird growth, right? So she scooped it out, 4 stitches, a little tiny thing like that, sent it to the path lab, and it was a weird thing, but it wasn't, cancerous thing. But, yeah, anything if it looks wrong to me, take it out. I don't wanna look at it. Right? And I just get paranoid. All right, so here we go. So, thick skin and thin skin. The epidermis is kind of aligned in layers known as what, please? Stratum, stratified, right? And this is a stratified epithelium. We're going to start at the very bottom layer and work our way to the top. So not from the top down, from the bottom up. And the strata, singular would be stratum, so one stratum, many strata. The bottommost stratum, here it is, which is sitting on the basement membrane. You can just barely see this bottommost stratum. It's typically 1 to maybe 2 rows of cells. The book says it's 1 row, it doesn't matter. But within this bottommost stratum, which is called, please remember, stratum basal, which makes sense, it's on the bottom. But also know this term, germinativum, stratum basal or germinativum. Germinativum, think of germinate and produces more, exactly right. So it's within that stratum basal or germinativum that you find most of the mitotic figures. Most of the cell division occurs within the stratum basal. Who's dividing, by the way, for more than any other cell? Which one is dividing? Starts with a K. Keratinocyte, right? To be sure, the other cells also divide, like the melanocytes and dendritic and sensory cells, tactiles, but not as often. Keratinocytes constantly have to divide, right? Because they're going to be dead in 35 to 45 days. Right? So that's the stratum basal or germinativum. And besides the keratinocytes, that's where the melanocytes are sitting. By the way, midterm question, if I ask you what's located within the stratum basal, it would be keratinocytes, these tactile cells, remember sensory nerves, and melanocyte cell bodies. And by that I mean the melanocyte, most of the cytoplasm and the nucleus, but remember these have arms, right? They go all the way up to the next stratum to inject the melanin, okay? So again, stratum basal, germinativum, what do we have there? Keratinocytes, they're dividing. We've got the pigment-producing cells, those are called what, please? Melanocytes, and then we have the sensory things called, what are they called?
Tactile cells.
Merkel cells. I kind of like Merkel, because then I remember within the basal, we have the keratinocytes and M&Ms, if that helps at all. But, yeah. So they're trying to not use personal names of the people that discovered these things. So if I were to discover anything in the research lab, they would not call it the Bagatsky anything, right? So that's why I quit research. No, not really. That's not true. That's not true. Anyway, so moving up from the stratum basal, we go into, look at that. This is a pretty big one. This would be the stratum spinosum. Here we have those dendritic cells. Remember, dendritic cells are looking for bad guys. And we have a bunch of keratinocytes. Now, let's go back to the stratum basal. Basal cell carcinoma. I will never ask you anything pathology related on an exam because I don't know what I'm talking about. But some interesting stuff though. Basal cell carcinoma originates within which stratum, would you think? Stratum basal, within the keratinocytes. Malignant melanoma also starts within the basal, but not by the keratinocytes, but these guys, melanocytes, right? Squamous cell carcinoma, not the best term, would typically originate within the stratum spinosum, right? Spinosum, stratum spinosum. What does that sound like? Spines, right? exam question. Which of the following might contain artifacts or distortions? Light microscopy, scanning electron microscopy, transmission electron microscopy, or all of the above? Where might you find distortions? Everywhere. Those are called artifacts, right? And when you prepare this tissue for viewing, so again, light microscopy, any types of electron microscopy, when you prepare that tissue, you subject it to chemicals and stuff like that. And the chemicals can alter the reality, right? That's why when you look at pathology slides, when you look for things like pap smear results and so forth, you can sometimes get a false positive, is that what it's called? Because maybe the preparation altered those cells. Anyway, stratum spinosum. This refers to the kind of spiny appearance over here on these keratinocytes, but in life they were not spiny. The tissue shrinks and the cells shrink, but they're connected where the desmosomes are connected, right? So they're still kind of attached, but they kind of shrink up and they end up with this artifact. They look spiny. They're not really spiny. You don't need to know that part, but you need to know artifacts. Always have a critical eye. What you're looking at in a slide might not represent what's actually there in nature. All right, so then we're moving up into the stratum granulosum. Granulosum, stratum granulosum. Granule, okay, so what kind of things might you find within these keratinocytes? Cytoplasmic little bubbly granules, including, the book gives you more stuff. Remember this, keratohyalin granules, keratohyalin granules. These are the precursors of keratin. So now these keratinocytes are making keratin. And those little granules, the keratohyalin granules, become keratin. They're morphing into that waterproofing protein, right? Now, going up from the stratum granulosum, now this is thin skin, it only has 4 layers. You go right into the stratum corneum. The uppermost stratum, this would be a good question. What do you call the uppermost or apical stratum? Would be stratum corneum. What is it made up of? Keratinocytes, and these are all dead. These are all dead keratinocytes, and they're basically bags full of keratin, and then those slough off. So what would I say? What would you call the apical or the uppermost stratum of both thick and thin skin? Doesn't matter. Would be stratum corneum. And then what is it composed of? Dead keratinocytes. They're done over there. Now, this is a diagrammatic of thin skin. Thin skin has how many distinct layers? 4. And thick skin has 5. So in thick skin, there's an extra stratum, and it's called the stratum lucidum. Do I have one here? Kind of, sort of. All right, so, well, if you believe this, I don't know. So, it's kind of off, right? By the way, what do you think all this business is? What's all this stuff going on? Look at that. Ooh, that's a sweat gland. That's a sweat gland, right? It's this little spirally thing, and they were kind of cool, and it releases sweat. Anyway, so, yeah, let's pretend that this is true. So we've got the basement membrane right here, we've got the dermis, and then we've got the epidermis. Let's go through the strata one more time. The bottommost one is the stratum basal or germinativum. Boom, escalator up would be stratum spinosum. Then, we're making the keratin granulosum. Here's in red, the stratum lucidum. Lucidum means clear. For some reason, looks clear-ish. And it makes thick skin thicker and more resilient or protective against ultraviolet radiation. Then we've got the stratum corneum on top. Okay? We have a couple more minutes. couple of more minutes, we did this. Oh, back to this, okay. It's not even a cute slide, but I don't know why I keep looking at it. Is that in your book? I'm not sure. So, any questions on the epidermis? We're good down the epidermis, right? Give me a couple more minutes, get your money's worth, right? It's free, but it's okay. Dermis, 2 parts to the dermis, right? The upper portion is called the papillary layer. It's loose CTP, loosely arranged. Deep to that, 80% of the dermis, and we'll end right here because I don't like this term. Deep to the papillary layer, you have the reticular layer. Why don't I like this term? Because it's not reticular tissue, it's dense, irregular CTP. One last thing. In thick skin, okay, what do you call these little, ridges? What are they called? Fingerprints? What are those? Those are actually sweat films, sweat prints. So what happens is in thick skin, the papillary layer is particularly pronounced and it kind of bumps up to the surface, right? So we have those ridges, those are your sweat prints, right? And sweat is deposited on top of it, right? So when you have a fingerprint or a palm print or a footprint, I guess, those are all specific to you. Isn't that interesting? How about in identical twins? Do they have the same fingerprints? Identical twins, same genetics. Huh? Identical twins? Nope. Completely different fingerprints. I know, because I'm married to one. We're just